Hi, and welcome to our second podcast. We're learning to predict ionic charges. To predict ionic charges, we have to understand the following things. What is a valence electron? What is an ion? How are positive and negative ions formed? And how can you predict whether an element will form a positive or a negative ion? So to do that, we have to really understand the periodic table. So the periodic table tells us a lot of interesting things. First of all, this is called group 1A. This is called group 2A. This is called group 3A, and so on. So you can number all the way to 8. So there we've numbered all the way to 8. Now this is going to mean something specific because it actually has to do with the valence electrons. Once you've completed the assignment that I gave in class, you should realize that each group actually represents the amount of valence electrons that an atom in the group has. For example, carbon will have 4 valence electrons, oxygen will have 6, so will sulfur, so will selenium. Fluorine has 7, helium, oddly enough, it has 2, neon has 8 though, argon has 8, krypton has 8, xenon has 8 as well. So we really know, except for helium, these numbers up here tell us how many valence electrons it has. Please recall that valence electrons, this is the Lewis dot diagram for fluorine. Valence electrons represent the outermost shell of an atom. So this is the Bohr-Rutherford for fluorine, and you can see that fluorine has 9 electrons to match up with its 9 protons. So right now this atom is neutral, but it actually has 9 electrons, but it has 7 valence electrons, because we only are concerned with the outermost electrons. Now this atom is considered to be unstable. So it's unstable, but it's also neutral, okay? So all atoms want to become stable. So in order to become stable, what's going to happen is we're going to have to gain 1 electron. And when that happens, every single one of these valence electrons has a pair. We now have 8 electrons. It will go from becoming stable, or it will become stable. But the thing as well is that it's no longer going to be neutral. It's going to have a charge. And the reason is it just gained 1 electron. And the protons and electrons are not the same anymore, so we have a charge. In this case, it would be a negative charge. So an ion is an atom with a different number of protons than neutrons. Now there's 2 types of ions that we can form. The first type is a cation. And this happens when you lose electrons. Okay, so when an atom loses electrons, it becomes a cation because it has more protons. The other type of ion that you can become is called an anion. And an anion is when you gain electrons. And that means you have more electrons. So the moral of the story is that if you lose electrons, you have more protons, that means you are positive. So a positive ion is a cation. If you gain electrons, you have more electrons, that's a negative ion. So atoms gain or lose electrons to become cations or anions because these are stable. Even though they are not neutral, they are stable. And they're stable because they have a full shell. And the first shell likes to hold 2, the second shell likes to hold 8. And this is why, for example, if we look at helium, it has 2 valence electrons. It actually only has 2 electrons in the first shell, and it is stable. And it doesn't become an ion because it has a full shell. And if we look at the noble gases, the similar thing happens. The other noble gases, for example, if you have xenon, it has 8, also a full shell. So these noble gases do not form ions because they are stable. So how are positive and negative ions formed? Well, if we take a piece of metal, for example, sodium, and I'm going to do this in class, sodium metal, and you put it in some water, what will end up happening is you will lose 1 electron to the water. And it will become a positive ion, and that sodium ion will dissolve in water. This means it dissolves in water, it's aqueous. So this is actually how you get a cation. When you give up an electron, you become a cation. Similar thing happens with a negative ion when it forms. Chlorine, for example. What will happen is it will actually gain electrons, okay? And we actually have to put chlorine as 2 because it's something called a diatomic ion. We'll get to it later. But what ends up happening is if you add some electrons to it, you will get negative ions, which are called anions. So how can you predict whether an element will form a positive or a negative ion? Well, it's pretty simple. If an atom has less than 4 electrons, it's going to lose electrons, and it's going to become a cation, which is positive. If you have more than 4 electrons, you're going to gain electrons. And when you gain electrons, you become an anion. So let's really look at this closely. Let's look at the periodic table. When we look at the periodic table here, you should notice from the last assignment that you did that there's 1 valence electron here, 2 valence electrons here, 3 valence electrons here, 4, 5, 6, 7, 8. So I said everybody that has less than 4, so all these guys are going to lose electrons, are going to become cations. And everybody more than 4, except for 8, these guys have a full shell. So it's messy, super messy, sorry about that. So these guys are actually going to become anions. So if you didn't know, there's a staircase right here. These are the metals. So cations are generally metals. And nonmetals over here are always anions. The ones in the middle share both characteristics, and we'll talk about those guys a little bit later, but they can actually do either or. They will turn into both positive and negative ions. So if we look at the periodic table again, this has 1 valence electron. That means it's easier for it to lose 1. So it's going to lose 1. So if you have less than 4, you'll lose 1. Okay, so it's got less than 4. Everybody in this row becomes 1 plus. Everybody in this row will become a 2 plus cation. We jump over here. Everybody in this column here, not row, column will be 3 plus. Everybody here, you're going to find out it's going to be 4 plus, 4 negative. Here you have 5, so to get to 8, it's going to gain 3, it will be 3 negative. Here you have 6, it's going to gain 2 to get to 2 negative. Here you have 7, it's going to gain 1. And here, there's going to be no ions are going to be formed. So if you need to know what charge, you can look at this periodic table and it will tell you how many valence electrons it has, and it will tell you what charge it should form in any one of these rows. We'll talk about these guys later. So let's prove it. Let's pick one of these guys here. Let's pick phosphorus. Okay, so if we look at phosphorus, it's in group 5, so that means it has 5 valence electrons. So if we draw phosphorus out, phosphorus would look like this. It's got 5. It has 8 in this shell, so I'm going to pair up after I half fill. That's got 5. Now we're supposed to end up with a 3 negative charge according to what I said. Let me prove it to you. So for this guy, this valence shell wants to be full. So to be full, it can either lose these 5 or it can gain 3 more. So if I gain 3 more, that means I've just gained 3 electrons. That means I have 3 more electrons than I do protons. That means I have a 3 negative charge.